Hi, in this video, we'll be talking about how computers encode images. So here's a question. How exactly are images stored and displayed on computers? We know that at the base of it, computers are only storing zeros and ones. It's not like we can really take an imprint of that image and burn it onto a CD. We need a way to represent an image as only zeros and ones. So really, we just need a system of breaking down an image into concrete values that can be stored. We know we can store numbers with binary, so that's really what we need to do, is find a system for turning an image into a sequence of numbers. We need a digital representation of an image. So how are we going to do that? Well, introducing pixels. Pixels are the building blocks of digital images. A pixel is the smallest element of a digital image. It is like the atom of a digital image. So if you look at any image on a computer and you zoom in really close, what you end up seeing is that there's actually all these tiny squares, each of which have their own color. From a distance, everything looks like smooth lines. You can have gradients, you can have depth, you can have shadows, but when you zoom in really close, it really just boils down to tiny, tiny squares, each of which have their own color. So we see that an image can really be represented as a grid of values, where each value encodes the color for that position. It is a grid of pixels, and each pixel has a constant color. So really we just need an encoding system where each color can map to a particular value. So what's an encoding system we can use? What's a good table that will map values to colors? Well, the simplest system would just be 0 being black and 1 being white. The 0 is off, there's no light, and the 1 would be a white because there is light. Just using this, we can make several pixelated images of black and white. We can add complication to the system later, but for now, let's just practice making images using only zeros and ones, black and white images. Let's explore this in the editor. So welcome back to the bit interpreter tool. We see that this time, the bits are being interpreted as colors rather than text. What's interesting is the bits are the same. We're always using zeros and ones. It's just a matter of the software. It's a matter of whatever program is interpreting these bits. That determines the actual result, what is displayed on the screen. So here we see the encoding table says that 0 results in a black pixel and a 1 results in a white pixel. Again, we can view the raw format. It's all in one line, or we can go pretty, and we can see each row here represents a full row in the resulting image. So if we just type a 0, that's a black, and a 1 is a white. And we can make full images like this. So I want to add one more layer on the bottom just to make the computer nice and stable. We see we've made the CodeHS logo using only black and white pixels. So this is one way we can make black and white images.